Hello, Rob here. This is lesson number 1. Enough futzing around, blah, 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 blah. We're going to try to learn something today. The first lesson is entitled Comparators. Why are we starting with comparators? Because they're fun and useful. This is a drawing I made before. It's a comparator. This is the logical symbol for it, something you'd see in a schematic. It doesn't have all the information, just enough to get us going. The comparator, what does a comparator do? What does a comparator do? It compares. Compares what? Voltages. We're going to get the voltages later, but let's just say for now, voltages. Those things you see on the scope. Voltages. There are 2 inputs here. They call them the positive and the minus, or the inverted and the non-inverted, or the up and the down, whatever, and there's an output. You could think of a comparator as an analog to digital converter. If that means anything to you. The signals coming in are up, every which way. The output is digital. Yes, no, 1, 0, period. That's all you get. Useful for certain things. We could, instead of saying inverted and non-inverted, we could just say it has 2 inputs. We're going to call one the in and the other the threshold. This will work for us. And then the output. I've drawn a little waveform here that looks like video. Good old black and white standard definition NTSC, could be PAL, video. What's missing? The chroma. We're simplifying matters. So there's no little burst. This is just luminance. Down here is the sync. These are the sync pulses. Up here is the video. If we imagine this video, this is the in, and there's a red line as the threshold, we're slicing the video. And we're saying, you know what? That video, someplace it's so high, it's so white, it's going to be high. Or it's so low, it's going to be low. All the areas down here low, all the areas up here high. We're going to see a pretty version of it on the scope momentarily. That is our comparator in a nutshell. And if that take was any good, I can erase this now. Do I dare erase this now? Sure, you're not going to see that anyway. La, 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 la. Now, I've already done this breadboard. I'm going to show you breadboarding because I've done it for 45 years and I'm pretty good at it. I've got some ways I do it. I have colors that mean things totally arbitrary. Of course, they're not arbitrary to me. They seem innate. But in fact, they're arbitrary. One nice thing about using particular colors for particular things, it helps troubleshooting. For instance, I make the +5. We're using only a +5 supply today. I make the +5 red. That's important. You don't want to be shorting that out. So one rail across the top here, this is a breadboard. And these guys that go across the top, we call them rails. Big important word, rails, we're going to get to in a minute. That's a rail, and everything across the top is going to be red. That's going to be 5 volts. The next guy down, I make it black, and black is the ground. Black is 0 volts. I'm going to bring, ground is so important, I'm going to bring ground down here. So we've got it on the bottom as well as the top. Okay, coming in here is video. That video is coming from a black and white camera. I'm gonna have to take a photo of that later because I have no camera on the camera. We're taking a black and white signal from that camera. If you're into such details, I'm taking the S video out and just the luminance. It's cheating. It's also a bit of time travel. 45 years ago, all we had were black and white cameras. That's all that was available to us. So we put color on them. That's how we got into colorizing, because we had black and white cameras. So the signal we're going to deal with is black and white, and that helps us for a couple of reasons. Okay, so the first thing we're going to do is put this signal, the first resistor we're going to encounter. Resistance is futile. Talk about resistance later. That's a 75 ohm resistor. We got 75 ohm resistors all over video. Doesn't matter whether it's NTSC or PAL or anything. CCAM, I'll bet. HD, always 75 ohms. So the very first wire goes into, this guy, this integrated circuit. He's an IC, he's a chip. So let's go back to the drawing board and draw this chip. What is that chip? Well, the schematic, the simplified schematic, looks like this, with 2 inputs and output. Well, that doesn't look hardly at all like this thing that's got legs on it. And by the way, be very careful. If that guy flips over and it's on the floor and you step on it, it'll stick right into, well, if you're like me and you're not wearing any shoes. Anyway, that's a chip. Today, we're going to meet one of my favorite chips of all time, the LM311. It's a comparator. It's a friendly one, an easy one to use, and it loves living down on the breadboard. So, we talked about it having a plus and a minus. What are all the other pins? Shall we think about the other pins? Sure, let's think about the other pins, because it gives us an idea what we're going to have to worry about later. There, in fact, we're going to draw it sideways, because that's how you typically draw it. 1, 2, 3, 4, 5, 6, 7, 8. All chips, the little guy, have this convention where they come down this way and go up that way. If it's 26 pins or whatever, it's 1, 2, 3, 4, all the way back up to the highest. Now, inside there is the comparator. And he goes up here. Okay, so pin 2 is this non-inverted. Pin 3 is the inverted. Pin 7 is the output. What are the other pins? Well, I'm going to give you the simplified answer to that, because this chip actually does some cool and subtle things, but let's go simple. Every chip has to have the lower rail, and the upper rail. Rails are your playground, the place you can work inside, the place you can't go outside of. It's meaningless out there, it's a void, don't go there, you have no control there. Our first circuit is very simple. We're going to have ground. Ground is drawn like that, and that's called the ground. Now, if you're going to make it prettier, is that better? That's the ground. Now, when I go for the positive power supply, I draw it like this. Kind of like the positive always comes from the top and flows down or something. Turns out, for reasons we'll worry about later, this guy also goes to the ground. Okay? So right now, if I lay this chip down on the breadboard, and I hook pin 1 to the ground, and pin 4 to the ground, and pin 8 to the +5, that guy's turned on. It's up. I can start putting inputs in. Let's talk about the output. Well, we'll leave some of these details to later, but I'm going to tell you that it is what's called open collector. It collects. It pulls down, okay? When it's high, it's not really going high. You got to pull it high. But when it's low, boom, it pulls it to the ground, solid. When it goes high, you're going to have to help it. So the first thing we're going to do, let's erase it all. Go back to the more schematic-y way of looking at this. We're going to go like this. We're going to go like this. Notice how I kind of took away all the complexity, but something I like to put here is this ground. And what that's reminding is this guy's going to pull low. The output is going to pull low. Well, what's going to make it go high? That sounds funny. We're going to use a resistor to go up to +5. So this guy pulls like the dickens down low when it goes low and pulls up with the resistance high. Let me stop here for a fundamental. Fundamental. Probably didn't think of that, but what is a resistor anyway? Let's take a little detour. Resistance is a funny thing because you think of it sort of like politically or human terms as the higher the resistance, the more the resistance is great. Down on the circuit board, I think of it almost the opposite completely. And I'll give you an example. I've got a scope and a scope probe. And I put that probe down in and I see things. I want it to be as though it's not there at all. Don't you be messing with it. No Heisenberg, just Heisenberg, stop. I want the probe to go down and be as though it's not there. I want you to sample. I want you to tell me what's going on, but don't change anything. What's it like if you weren't there, type of thing. Well, they call it the impedance. For now, let's say it's the same as the resistance. That probe comes in, it's very high. Very, very high resistance. The higher, the better. It's 10 megohms, 10 million ohms. Now you would think, that's a lot of resistance. Well, yeah, it is. But in this case, it means I'm not even there. In fact, the higher the resistance goes, pretty soon you get to the air, where like nothing's happening. So resistance. Conversely, as the resistance gets lower and lower and lower and lower, that's when it's like really, it's strong. A car battery has a very low resistance. Lots of current comes out. So that's what I'm saying. Resistance feels funny. We're going to use a very inexpensive power supply. Some people might call it a Woolwort. All right. And what this guy is going to do, and this is my power switch, it's on. Okay. We connected it to our circuit, over to the circuit. That's our +5. Okay, so +5, cool. And anywhere I want it in the whole circuit, I'm just gonna reach up and say, that's +5, yay. And anywhere down here at the other end, the lower rail, why is it called a rail? Is the ground. Everything sure as heck better be between those two rails. Why? Because if it's outside, it means nothing. I can't detect it. I can't think about it. The scope doesn't care. The scope will show you everything, but my circuit can't think about it if it's not in there. I cheated a little bit by using a good old Radio Shack video distribution amplifier. Distributes audio too. And it has a positive bias. Positive bias. It just means the video is up in the air or something. The video is going to be up in between these two guys. Very helpful. If it fell down too low, and there are reasons that can happen, the comparator would go, I can't see down that far. I'd love to pick off your saying, but it's buried in the ground. Video is down here somewhere. We'll look at some much prettier scope version of this, okay? And we want to pick off that sink. Okay, I know where the video came from. It came from the camera. I plugged it in, I terminated it. Fine, where do I get the red line? Where do I get a voltage somewhere between 5 and ground? I've got an expensive power supply over there. I can make voltages. No, that's not such a good idea. I'm going to use a potentiometer. Who names these things? Let's make a potentiometer, which gets back to what's a resistor. You've seen potentiometers. They're everywhere. Typically, it's like a pot. Turn it up and down. Okay, fine. Sometimes it's a fader. Slide it up and down. Okay, what's going on inside? Well, we've seen a resistor. We had that pull-up resistor, right? Okay. I'm going to draw a resistor here, and it's going to go from the top to the bottom. Yeah? Okay. But I'm going to tap at a certain point in that resistor. Okay? In a pot, that resistor goes here, and there's a little thing going, right? Okay. In a fader, they literally have a guy that goes up and down. But you get the idea. Hopefully you get the idea. Okay. So if this is a 1K, and I'm in the middle, okay? It's really like two resistors. And those two resistors are 500 and 500. Huzzah! They add up to 1K. Get the K thing, all right? Thousands, M's, millions. That was in the introduction. No, it wasn't. I'm introducing it now. Okay, 1K, 500, 500. Cool. One might imagine that if I'm halfway between 0 and 5, I'm at 2.5 volts. Yeah? Okay. Cool. As the fader goes down, the voltage goes down. As the fader, 2.5 volts in the middle. 2.5 volts, okay? In fact, we could draw that resistor going the whole length, but you get the idea. As the resistor goes down this way, it could be like 1 volt, 1 volt, 0.5 volts, right? Same thing, up and down. So that's how we're gonna make our line. And I'm using these adorable little tiny pots on the breadboard because they're cute. And otherwise I have to wire up a pot and run around the numbers. At some point we're gonna show how I do that, how I add components and I build these cool things with plastic panels. But right now, simple. It's all about simple. All right, so that's how we're gonna get our voltage with the potentiometer. And we're gonna find that that pot has got way too much reach. Why? Because I, to keep things simple, went all the way from +5 down to the ground. You can see I draw my grounds really round. Cool. Where's the video? It's down here. What happens when it's way higher? Nothing. When it's way lower? Nothing. So it's going to be a range on that pot that's ridiculous. But we're just like experimenting now, so that's okay. All right. Had enough whiteboard? I know I have. So let's come back over here. I've got this groovy look-down camera. Whoa. Okay. And let's look at the scope. Now here are these wonderful probes. Love the probe. Probes are sacred. Don't hurt your probes. It's like poking yourself in the eye. Ouch. So, and the cool thing about this scope is I've got 4. I don't think I have a shot. Do I have a shot of the scope? No. I'll take a photo. You've seen it. Certainly. I'll take a picture of the scope. Sure. And it's like color-coded, okay? Which makes life easy. In fact, each of the probes has a little colored band so I can see. I want to see that sink. Let's look at the sink. What I want to show is these are the 2 inputs of the comparator and that's the output. The output's actually swinging 5 volts. You know, it's really up here like that. But we made it smaller so we can see the darn thing. Now I'm going to adjust that threshold. Let's do it so I can see. See I'm moving that blue guy up and down? Well, I didn't get any sink there. But there I am picking off the sink. It's picking off the sink with your left hand so you can see how... Okay, picking off the sink. There it is. Cool. That's all well and good. How about picking off that video? These are the 2 inputs going to the second comparator. I'm going to move that threshold up, and I could pick off sync again. Useless. I can go up and up and up and up. Pretty soon, I'm so high. I'm so high, man. Nothing there. Blue, blue, blue. And actually, let's combine them together, those 2 signals we saw. I'm going to do that by putting him back in here, him, it, them. Put that back there. And the blue. Am I blue? Or are you? We're going to look now at our final product out of this circuit. In fact, we'll go up and draw it. And let's slide it down here. And by George, that looks like honest to goodness video. Right? That works. And what a cool effect, eh? That's Rob, like a poster. Posterization. I can set that threshold so I look almost kind of cool. All right.